Find the index of the nth item in a list. I want to find the index of the nth occurrence of an item in a list. E.g. What is the index of the nth true? If I wanted the fifth occurrence, fourth if 0 indexed, the answer is 10. I've come up with. Note that x.index returns the first occurrence or the first occurrence after some point, and therefore as far as I can tell is not a solution. There is also a solution in number py for cases similar to the above, e.g. using cum sum and where, but I'd like to know if there's a number py free way to solve the problem. I'm concerned about performance since I first encountered this while implemented a sieve of Eratosthenes for a project Euler problem, but this is a more general question that I have encountered in other situations. Edit, I've gotten a lot of great answers, so I decided to do some performance tests. Below are timite execution times in seconds for lists with len elements searching for the 4000 foot th/1000 th true. The lists are random true/false. Source code linked below, it's a touch messy. I used short/modified versions of the posters' names to describe the functions except list comp, which is the simple list comprehension above. Hettinger's Itertol's solution is almost always the best. Taman's and Grady's solutions are next best for most situations, though the list comprehension approach can be better for short arrays when you want the nth instance such that n is high or lists in which there are fewer than n occurrences. If there's a chance that there are fewer than n occurrences, the initial count check saves time. Also, Grady's is more efficient when searching for numbers instead of true/false, not clear why that is. Equum solutions are essentially equivalent to others with slightly more or less overhead. Equum_occur is approximately the same as Taman's solution, while equum_occurrence is similar to list comp.
The answer from @Taman using list.index was great. For what it's worth, here's a functional approach using the itertools module. It works with any iterable input, not just lists. The example is nice because it shows off how to effectively combine Python's functional toolset. Note that once the pipeline is set up, there are no trips around Python's eval loop. Everything gets done at C-speed, with a tiny memory footprint, with lazy evaluation, with no variable assignments, and with separately testable components. IOW, it is everything functional programmers dream about. Smiley face. Sample run.
I can't say for certain that this is the fastest way, but I imagine it'd be pretty good. The answer is I. If efficiency is a concern, I think it's better to iterate the normally, O, N, instead of list comprehension, which takes O, L, where L is length of list. Example. Consider a very huge list and you want to find the first occurrence n equals 1. It is obviously better to stop as soon as you find the first occurrence.
If you're concerned with performance, you are best off seeing if there are algorithmic optimizations you can make. For example, if you are calling this function many times on the same values, you may wish to cache previous computations, e.g. once you find the 50th occurrence of an element, you can find any previous occurrence in O1 time. Otherwise, you want to make sure your technique works on lazy iterators. The most inelegant and performance-happy way I can think of implementing it is as If you really care about the performance difference between enumerate and other techniques, you will need to resort to profiling, especially with the number py functions, which may resort to C to preprocess the entire stream and support O1 queries.
Note, here Z is the nth occurrence.